In Chapter 6, we cover marginal distributions, conditional distributions, relative risk and odds ratio for 2x2 contingency tables, and Simpson's paradox. Categorical variables. Review. Categorical variables place individuals into one of several groups or categories. The values of a categorical variable are labels for the different categories. The distribution of a categorical variable lists the count or percent of individuals who fall into each category. When a dataset involves two categorical variables, we begin by examining the counts or percents in various categories for one of the variables. A two-way table describes two categorical variables, organizing counts according to a row variable and a column variable. Two-way contingency table. In 2017, the National Center for Education Statistics projected the number of academic degrees to be awarded in 2020 to 2021 for men and women, Table 6.1 of the textbook. What are the variables described by this two-way table? Their sex and degrees conferred. How many degrees were conferred to the nearest 1,000? So 3,900 degrees were conferred, which rounds to 4,000 approximately. This is how data are collected. Okay, so you can see there are cells. So you have columns of degree and sex. So associate and women are shown. And then professional or doctor and men are shown. So you have a set of rows and columns with the two sets of variables for each row titled, row of 0, 1, 2, 3, 4. And then you put them into tabulated data. And then you have your two-way contingency table, which has the degree conferred, the level of degree conferred as columns, and the sex levels of men and women as rows. And then you have totals for the rows and totals for the columns at the right side and the bottom. Marginal distribution, 1 of 3. The marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of that variable among all individuals described by the table. Note: percents are often more informative than counts, especially when one is comparing groups of different sizes. To examine a marginal distribution. 1. Use the data in the table to calculate the marginal distribution in percents of the row or column totals. 2. Make a graph to display the marginal distribution. Okay, so there's two sets of marginal distributions, one for sex, the one variable, and one for degree conferred, the other variable. So you take the totals of, let's say the sex, like men total, and then the women total, and then you divide by the total number of participants. So then you get a percentage of how many participants were women and how many were men. And the same thing for degree conferred. You take the totals of each degree conferred, and then you divide by the total number of degrees conferred to get a percentage. So the total you're dividing by is the same in both cases, which makes sense because for each degree conferred, there was one participant obtaining the degree, so those numbers would be the same. Conditional distribution. Marginal distributions tell us nothing about the relationship between two variables. A conditional distribution of a variable describes the values of that variable among individuals who have a given value of another variable. Use software to generate a side-by-side bar graph, a segmented bar graph, or a mosaic plot to compare distributions. A segmented bar graph is a bar graph for presenting data about two categorical variables in which each bar is divided into parts. Each bar represents the observations that take a particular value of one variable, and the length of each part of the bar represents the proportion of these observations that take a specific value of the second variable. A mosaic plot is a segmented bar graph in which the width of each bar represents the proportion of all observations that fall into the category that the bar represents.